Do you feel ignorant because you don't know numbers? You don't know which one go which way and they got all these marks and things on them? I know, honey, it's hard, but there is a solution. Fort Bend Tutoring. And now here go Mr. Whit. Explain math to us, Mr. Whit.
Hello ladies and gentlemen, this is Mr. Witt with Fort Bend Tutoring, and today's tutorial is going to be about simplifying algebraic expressions. There are two things to keep in mind when working with algebraic expressions. The first is being able to tell how many terms you have in the expression. Remember that terms are separated by plus or minus signs. That multiplication and division does not separate terms. The second thing to keep in mind and to be aware of is that when you're dealing with simplifying algebraic expressions, oftentimes they're asking you to combine like terms. So that means that you need to know when you have like terms. Well, like terms are when you have the exact same variables and the exact same exponents on those variables. That's the only time you'll be able to add or subtract terms together. Alright, so here we have some examples starting out with A here. Alright, I got 5x minus 3x. These are like terms, ladies and gentlemen, and not only that, I have two terms. The first term is 5x, the second term is negative 3x. Remember that a minus sign is the same thing as a negative sign. So when I'm looking at the terms in the expression, the first term is 5x, the second term is a negative 3x. That's right, that minus sign, that negative sign stays with that second term. Alright, well, being as though these are like terms, we can go ahead and combine them, which means you're going to add or subtract. So you're going to combine the coefficients and the variables stay the same. So what I mean by that is we're going to subtract 5 minus 3 to get 2, and then our variable x remains the same. The only time your variables will change is when you're multiplying or dividing. Alright, so here we have our answer, 2x. Let's go ahead and box it up. Boxing up the answer. Done and done. Alright, next problem. We have problem B. I have 2x plus 16x minus 7y. The first thing I want to do is recognize that I do have like terms within this expression. Here, my first term is 2x, the second term is 16x. So noticing that these two terms both have an x, I know I can combine them. So you simply combine the coefficients, the numbers in front of the variables. So I'll end up with 2 plus 16 to give me 18x, and then this negative 7y, that third term of the expression, is not a like term. It doesn't have the same variable as these other two terms, therefore you cannot subtract it, so just bring it down as negative 7y and done. There's nothing else that you can do with this expression. This is the answer. Done and done, ladies and gentlemen. Alright, moving on to problem C. In problem C, we have 4x cubed y minus 12xy squared plus x cubed y. What we're looking at, ladies and gentlemen, is a trinomial. That's right, we have three terms. The first term is 4x cubed y. The second term is negative 12xy squared. The third term is x cubed y. So we need to know if any of these terms are what we call like terms. Remember, like terms have the exact same variables with the exact same exponents on those variables. So it turns out that my first term of 4x cubed y and the last term, which is positive x cubed y, are like terms. That middle term there is not like the other ones because the x is to the first power here. Notice that you don't see an exponent, so you assume it's 1, and then your variable y is to the second power. That's different from the other two terms. So what we'll do now is we'll combine this. We have 4x cubed y as well as 1x cubed y that we can add together. 4 plus 1 gives me 5x cubed y. Then, bringing down that unlike term, I'll bring down that negative 12xy squared, and this is going to be my answer for problem C. Let's gift wrap this answer. There we go. Alright, let's move on to our next example, ladies and gentlemen. In our next example, we have problem D as in dog. Alright, here I'm multiplying 12x squared times 3x cubed y to the fifth power. Now, if you're unfamiliar with your exponential rules as far as multiplying like bases and things like that, go ahead and check out our video, Integers as Exponents. I'll put a link right down here. So what we'll be doing in this problem is we'll multiply the coefficients together first. So I'm multiplying 12 times 3 to give me 30. 36. Then I'll be multiplying the variables together. Anytime you multiply like bases, when you have the same variable multiplying times itself, you add the exponents. So x squared times x cubed will give you x to the 5th power. And then, since I only have that y to the 5th power to multiply, then you'll just bring that down as it is as the last part of your result. All right, and that's the answer. There it is. 36x to the 5th power, y to the 5th power. Oh yeah, there you have it. That was problem D. All right, so here's our next problem, ladies and gentlemen. Problem E. With E, we have 12x plus 6 divided by 3. Now, there are a few ways to solve this problem, so I think I may just go ahead and show you both. So let me go ahead and write this out again as 12x plus 6 divided by 3, and the first way I'm going to show you is that you can expand this fraction. So anytime you have a fraction, you have division going on. So in this expression that they're asking us to simplify, we could break this up into 12x divided by 3 plus 6 divided by 3. And then from there, you can simplify the coefficients, knowing that 3 goes into 12 4 times, so this term becomes 4x. And then we know that 6 divided by 3 is 2, so we just simplify that expression. Done. That's the answer, 4x plus 2. Another way to attack that same problem, ladies and gentlemen, is to factor the numerator first. So what we could do is we could go ahead and show that 12 and 6 can both be divided by 6. So if I factor out the 6, I'll end up with 2x plus 1. Then that's all over 3. From there, we can simplify this by saying that 3 goes into itself once, that 3 goes into 6 twice. All right, so that means that you'll end up with 2 times 2x plus 1. After I have this, I can use my favorite property in the world, which is the distributive property, to get my arrows popping, ladies and gentlemen. And I can just go ahead and distribute here, and I know that 2 times 2x is 4x, and I know that 2 times 1 is 2. So we once again end up with our result, 4x plus 2 for part E. Let's box that up. Boxing up the answers, ladies and gentlemen. All right, so that's 2 different ways to attack that problem. All right, so let's continue on with the lesson. Here I have problem number 1. That's right, so all of those lettered problems were just a precursor to the nitty-gritty. So this is the real first problem of this tutorial, ladies and gentlemen. We're going to start out by looking at an expression that is common when you're simplifying algebraic expressions, and that is the opposite of negative 2a plus 9b minus 5c. What you need to know, ladies and gentlemen, is that anytime you have a negative sign standing alone on one side of a set of parentheses, it's the same thing as rewriting this as negative 1 times negative 2a plus 9b minus 5c. So once I'm showing that this is truly negative 1 that's multiplying on our quantity here, all we have to do now is distribute. That's right, get my arrows popping. Okay, so we'll just multiply everything by negative 1 now. So negative 1 times negative 2a will give me a positive 2a. Negative 1 times positive 9b is a negative 9b. And finally, negative 1 times negative 5c is positive 5c. So this is my result, ladies and gentlemen. And notice, I don't have any like terms that I can combine. All right? That's it. So all I had to do was basically just change all the signs inside the parentheses, right? So if we're just looking at our original problem from number 1 here, all we did was change all the signs of all the terms inside the parentheses. And that's it. We're going to box this up now because it's done. Boxing it up. That was problem number 1, ladies and gentlemen. Let's move on to our next problem. All right. Problem number 2, ladies and gentlemen, here we are. We have 12a minus the quantity of 5a minus 9. Once again, anytime you have a negative in front of a set of parentheses, that means you're going to find the opposite of everything inside the parentheses. In other words, you're multiplying by negative 1. All right, so I'm going to get my arrows popping here, okay? I'm about to distribute negative 1 inside of those parentheses. So I bring down the first term, 12a. Notice how I'm writing my result from left to right here. I have a negative times a positive, that gives me negative 5a. I have a negative times a negative, that gives me positive 9. After you distribute, always look to combine any like terms you may have. So I do notice that in my result here, I have 12a and negative 5a that can be combined because these are like terms due to a being to the first power in each term. Let's go ahead and combine those. We have 12a minus 5a, and remember, you just subtract the coefficients. So the result is 7a. And then you bring down that positive 9 and done. And done. It's over. It is over. Put a box around your answer, please, right now, because it's done. That's right. We're done. Moving on, problem number 3. In problem number 3 here we have 2x minus 4y minus 3 times the quantity of 7x minus 2y. Now, instead of just having a negative in front of our set of parentheses in this expression, we actually have negative 3. Keep that in mind because it's negative 3 that you'll need to distribute inside of the parentheses. Remember, you're always going to be working with the order of operations. So, yeah, we are checking inside of the parentheses first, but we don't have anything we can do with that, right? So immediately outside of that is multiplication, and multiplication is going to come before any subtraction that you may be tempted to do first. All right, the multiplication goes first in this expression. So let's multiply that negative 3 to everything inside our parentheses. We'll be bringing down 2x. All right, we'll also be bringing down that negative 4y, and now we'll be multiplying by negative 3. So negative 3 times 7x is negative 21x. That's right. Then multiplying negative 3 times negative 2y, a negative times a negative is a positive, and 3 times 2 is 6, and I bring down that y for good measure. Remember that anytime you distribute, your next step is to see if you can combine like terms. And in this case, we can. It's common to write your answer in alphabetical order. So that means I'll be looking at terms with the variable x first. I have a positive 2x and a negative 21x. Combining these two terms here, you're going to keep the sign of the largest number here, that 21. So I know the result will be negative 19x when combining 2x and negative 21x. Then I get to combine the y's together. All right. So I have negative 4y as well as positive 6y. Once again, unlike sign subtracting, you keep the sign of the biggest number here. So the 6 is the largest, so I'll have a positive result, and 6 minus 4 is always 2, and remember that variable remains the same. And that's the answer for problem number 3. Box it up. Red boxing it. All right, that's problem number 3, ladies and gentlemen. We are moving on to problem number 4 now. All right, so here it is. In problem number 4, we have 5 times the quantity of 3x plus 2y plus 2 times the quantity of 7x minus 4y. Once again, anytime you have an expression, you definitely use the order of operations. We can attempt to start inside of our parentheses, but within each set of parentheses here, you have unlike terms. There's nothing you can do. So outside of those parentheses, you do have a scalar, a number, a term multiplying with everything inside of the parentheses here. So I'm going to get my arrows popping. You see that? All right. Got my arrows popping just like that. Okay. And now I'll distribute. Let's distribute. We have 5 times 3x. That gives me 15x. I have 5 times 2y. That gives me 10y. I have 2 times 7x. That gives me a positive 14x. I have 2 times negative 4y. That gives me negative 8y. And then we'll add 15x plus 14x to give us 29x, and then combining our y's together, 10y minus 8y, just 10 minus 8, will give us a positive 2y, and this is our answer, 29x plus 2y. Let's go ahead and put a box around this. Done and done, ladies and gentlemen. That's problem number 4. Let's move on to our next problem, problem number 5. All right, so problem number 5, we have the quantity of 3y to the 4th power times negative 6y to the 3rd power. What we'll do here is we'll be multiplying our coefficients together first, and then adding the exponents on those like bases right there, okay, in order to simplify this expression. Multiplying 3 times negative 6, you'll end up with negative 18, and then anytime you multiply like bases, because those variables are the same, you add the exponents. So I'll end up with y to the 7th power, and this is your answer for problem number 5. Done and done, ladies and gentlemen. Let's turn the page. For problem number 6, we have 5x squared y times negative 3x cubed y to the 4th power. So here, multiplying this out, I have 5 times negative 3. That gives me negative 15. We're multiplying our like bases. X squared times x cubed gives us x to the 5th power. Then we'll have y times y to the 4th power. This exponent on y is to the 1st power. So adding the exponents together, you have 1 plus 4, which gives you y to the 5th power, and done. All right, so your answer, negative 15, x to the 5th power, y to the 5th power. Boxing it up, ladies and gentlemen. Boxing it up. Continuing on. Problem number 7. In 7, we are multiplying a binomial times a binomial. Now, if you want to see more problems like number 7, check out our video called Multiplying Binomials, all right? I'll put a link right down here for you to check those out. So here, we will be simplifying this by multiplying and then combining our like terms. So I like to get my arrows popping on problems like this, all right? So that's exactly what I'm going to do. I'm going to get my arrows popping. So multiplying 4x squared times 4x squared gives me 16x to the 4th power. Remember, multiplying like bases, you add the exponents. So that x squared times that x squared gave me the x to the 4th power here. Then multiplying 4x squared times 5y, that gives me positive 20x squared y, just like that. Then I'll be multiplying negative 5y times 4x squared. That gives me negative 20x squared y. All right. And then finally, I'll be multiplying negative 5y times positive 5y. So a negative times a positive is a negative 25y squared. Done and done. From there, we just finished distributing. So what's the next thing I need to do? Yeah, it is. I need to combine any like terms I may have. And check this out. My middle terms, yeah, they're like terms. How do I know that? Because the x is to the 2nd power and the y, they're both to the 1st power. So we can combine those. So 20 minus 20 is 0. In other words, this cancels out. Get out of here. Yeah, get rid of that. And so just go ahead and bring down that 16x to the 4th power. And that negative 25y squared. And that, ladies and gentlemen, is the answer to problem number 7. We're going to go ahead and box this thing up. And yeah, I hate that 2 as well. So let's fix this 2 because the 2 is ugly. And we're going to make it look better. There we go. That's a much better 2. Is that not a much better 2? Give me a comment and tell me how good that 2 was compared to the one before it. All right, there we go. Let's go ahead and box that up. Red boxing it. Okay, ladies and gentlemen, we're on to our last and final problem for this tutorial for simplifying algebraic expressions. Here we have problem number 8. And yes, we are multiplying rational expressions. But sometimes, depending on the textbook, they'll give you a problem like this and say, simplify. So we're simplifying an algebraic expression. But if you want to see more problems like this, check out our video called Multiplying Rational Expressions. All right, so here we go. The first thing I'm going to do, ladies and gentlemen, is try to simplify the coefficients as much as possible. I'm looking at the 4, the 3, the 15, and the 24. And as long as you can reduce your coefficients diagonally or vertically, you're good to go. So what I'm going to do is this. I'm going to say that 3 goes into itself once, and that 3 will go into 15 5 times. I'll also notice that the 4 and the 24 can be reduced by 4. So 4 goes into itself once, and it will go into 24 6 times, like so. From there, I'm going to multiply straight across. So, multiplying my coefficients, I know that 1 times 5 is 5, right? And then, x cubed times x gives me x to the 4th power. Then, y squared times z to the 4th power. I'll just write that next to one another. We'll have y squared z to the 4th power. All of that is going to be over multiplying 1 times 6, that gives me 6. I'll have this x squared here. I'll have y to the 7th power, and then I'll bring down that z to the 5th power, like so. What you should know about your exponents, ladies and gentlemen, is that the base will remain wherever the largest exponent is. So I know I'm going to have 5 in the numerator. I know I'll have 6 in the denominator. And my variable x will remain on top because I'm comparing a 4 to a 2. Yeah, 4 is bigger. So that means that the x remains on top. And all you'll have to do is subtract the exponents from here. So 4 minus 2 leaves me with 2 x's in the numerator. All right? Check out that 2. That's a decent 2 for me. I'm really proud of this 2 right here. Okay? Just keep that in mind. Then, as I look at my y's, all right, the y variables, I have y squared over y to the 7th power. Remember, the base remains wherever the largest exponent is. So for my variable y, my y will remain on the bottom because the 7 is bigger than the 2. From there, you're going to simplify this by subtracting the exponents. So 7 minus 2 gives you y to the 5th power. That is an ugly 5. Oh my God. Let's fix it. It was so, oh, that's not much better. Yes, that's a good 5. That is a decent 5. Okay, I'm proud of that one. Then, looking at your z's, you have z to the 4th power in the numerator, z to the 5th power in the denominator. Where do you have the most z's? Yeah, in the denominator, on the bottom. So z remains on the bottom, ladies and gentlemen, and all you have to do is subtract the exponents here. 5 minus 4 is 1, and guess what? You don't even have to write the 1. Just leave it as z, and it's a-okay. This is the answer to our last problem, number 8. Yeah, 5x squared divided by 6y to the 5th power z. This is the answer. Let's go ahead and box that up, ladies and gentlemen. There you go. All right. Well, ladies and gentlemen, it's been fun. Oh, yes, it has. This is Mr. Witt with Fort Bend Tutoring, asking you to please rate, comment, and subscribe. Go ahead and subscribe. And if you're able, please donate. That helps us bring you more free math videos from me, Mr. Witt, and Fort Bend Tutoring. Peace.
We certainly hope you enjoyed today's presentation by Fort Bend Tutoring. Did you understand the program? Would you like to rate us or give us some feedback or subscribe to us? You could do all that on tutormemath.net.